This is an example of a dependent samples or paired samples t-test. As you can see from the formulas up top, we have a statistic, which is the t-statistic over here. We're going to take a sample mean difference and find the difference between that and the population mean difference. Set that over the standard error of the mean difference, and we can see that the formula for the standard error is the one that we've been using, the standard deviation over the square root of the sample size. So let's read the example. A variety of research results suggest that visual images interfere with visual perception. In one study, researchers had participants watch a screen looking for brief presentations of a small blue arrow. On some trials, the participants were also asked to form a mental image. For example, imagine a volcano. The results for a sample of n equals 6 showed that participants made an average of a mean difference of 4.3, more errors while forming images than while not forming images. The different scores had a sum of squares of 63. Do these data indicate a significant difference between the two conditions? Use a two-tailed test with alpha equals 0.05. So what we have here is we have participants who are all going to take a test twice. So each participant is going to have two scores. One of the scores is going to be from them trying to detect that small blue arrow, and the other score is going to be from them trying to do that but while forming a mental image. So the point is to see whether forming a mental image actually produces a difference between the scores. So each participant has a different score that is taken by subtracting the first score from the second one. And then all of those scores for each participant are added up, and you can find the average of that. That's what this mean difference is. So we want to see whether that's more significantly different from 0. So 0 is implying that there is no difference between those two different experimental conditions. So let's go ahead and start working out this problem. The first thing that we do is we identify the information that we're going to need. So obviously we're going to need this. We're going to need the sum of squares. We need to know that it's going to be a two-tailed and that our alpha level is going to be 0.05. We need to know the sample size. Okay, so let's start with the very first step, which is always to state the null and the alternative hypothesis. So the null hypothesis is that the population mean difference is equal to 0. And the alternative hypothesis is that the population mean difference is not equal to 0. So the second step is to draw a sketch with a shaded region. So in order to do that, we have to figure out where we're going to shade. So we need the t critical value, which is going to be the point at which we can shade that area in the graph, which represents the area of rejection. So what we need to know is we need to know the alpha level. So that was at 0.05. We need to know that it was a two-tail. And we need to know the degrees of freedom, which is n minus 1. And our n was 6. We have 6 minus 1, which equals 5. Okay, so now that we have this information, we can figure out what the t critical value is. And for this, we're going to need our t-table. So for the t-table, the first step is to locate what tail you're going to be working with. So you can see the first two rows. The first row is one tail, the second row is two tails. So we identified that we're going to do a two-tail, so we're going to scan row-wise across, until we reach our alpha level, which was 0.05. So we're going to locate ourselves here on the row and then scan over to 0.05, which is the third column. Now we're going to begin scanning downward column-wise until we get to the degrees of freedom. And the degrees of freedom are listed on the leftmost column here, and you can see that the number is increasing as we look downward. So we're gonna scan down this column, the 0.05 two-tail, until we get to the degrees of freedom 5, actually, because we had 6 people in our sample. So you can see here that it's 2.57. So this being a two-tail, we're gonna do positive and negative 2.57. So now we can actually do our sketch. So let's do it down here in the corner. So our critical cutoff value is going to be 2.57, and this is centered at 0. We want to see, oh, actually it's a two-tail, not a one-tail. And so that's negative 2.57. So it's a two-tail, it's centered at 0, and we want to see whether the absolute value of our statistic, of our obtained t, is bigger than the absolute value of our t critical value. So in other words, it's got to be bigger than 2.57, or it's got to be smaller than negative 2.57. So now that we did our graph, we can actually start calculating. So what do we need to calculate here? So we're going to have to, looking at our formula, we're going to have to calculate the standard error. So that's standard deviation over the square root of n. We don't actually have that, so we have the sum of squares. So that's part of the formula for variance. So the formula for variance is represented by s squared, is the sum of squared over the degrees of freedom. So our sum of squares is 63, and our degrees of freedom is 5. And if you punch that into your calculator, you'll get 12.6. Okay, so in order to find the standard error, we need the standard deviation and not the variance. So standard deviation, we just got to take the square root of the variance. So let's put that over here. If we take the square root of the variance, we have the standard deviation. So the square root of 12.6 is, I'm going to put it on the bottom here. Square root of 12.6 is 3.5496. Let's round that to 3.55. 3.55. Okay, so that's our standard deviation. Now we can actually calculate the standard error. So let's do that right here. Let me draw a little line here to separate this. And we're going to do standard error. Standard deviation is 3.55 over the square root of the sample size, which was 6. So we have 3.55 over 2.4494. Let's do 2.45. 2.45. And that's going to give us, I'm going to put it down here. And that's going to give us 1.4489. We'll round it to 1.45. 1.45. So that's for standard error. So this is the bottom part here of our final formula, which is to take the sample mean difference and subtract the population mean difference. So the population mean difference is always equal to 0, so that component is just 0. Really, we're just going to take the sample mean difference and set that over the standard error. So let's find a little room over here, and we're going to do So our t is going to equal mean difference minus, I'm just going to write it in the formula here, mean difference, and that is equal to 4.3 minus 0 over the standard error of 1.45, and that whole thing is equal to 2.9655, so we're going to go with 2.97. So that's our obtained t. So now let's plot that, 2.97. So let's go back to our chart here, and this is 2.57 is here, so 2.97 is over here somewhere. 2.97. So it's in the rejection region. That means that our final decision is going to be to reject, let me fit that in here, reject the null hypothesis. Okay, so we do actually have evidence that there's a significant difference, that the mean difference is significantly different from 0, meaning that the subjects who form the mental image, forming a mental image actually does create a significant effect. Let me leave those calculations here so you can see them.